Something to think about here in 113 before we get started is that as two wheels run together, the arc of their contact point, the arc that is formed between those two wheels rubbing together, will be the same length, but obviously on a littler wheel, that length laid out on a littler wheel might look longer to us than on a bigger radius wheel. So these arcs are equal, but they are not equally like if I section this out, that isn't the same angle as this one, okay, because one's smaller than the other. So we'll get started here with how we set this up now. I'll clear that off. Since the arcs are equal to each other, one thing we might just challenge ourselves to do is make a relationship here of S equals R theta for the smaller wheel and S equals R theta for the bigger wheel. And what we could really do then is say, well, R theta equals R theta of the small wheel. Sometimes we might abbreviate R theta of the small wheel would then be equal to R theta of the big wheel. Okay, so maybe we can do that here. The radius of the small wheel is 5.23 centimeters. And theta of the small wheel we know is 60. It says the smaller one rotates through 60 degrees, but that's worthless to this formula, right, because it's in degrees. So let's go ahead and change 60 degrees to radians. And just for simplicity's sake, this kind of reduces kind of nice, so I'm going to do that. It's just pi over 3. So that's pi over 3 radians. Now the question is, through how many degrees does the larger wheel rotate? So we don't know the angle of the bigger wheel. So we do actually know the radius of the bigger wheel is 8.16 centimeters, but we don't know the angle of the bigger wheel. So what we're going to really do here is, to get the angle of the bigger wheel, we are going to divide by 8.16 centimeters, all of this stuff over here. And it says, when we get that, we're going to be surprised. It's not really a nice, neat answer, but we'll figure that out. It's going to be a radian, right? Because the formula returns back radians. And the question was through how many degrees, to the nearest tenth, in fact. So what I'm punching in my calculator is exactly this, 5.23 times pi divided by 3, enter. Get that as an answer of 5.47-ish, divided by 8.16, enter. Turns to a radian measure of 0.67118, so on and so forth. But since it says we want to know this in degrees, and this is a radian measure of the angle, we need to use the idea that 180 on top of pi is how we would convert that. So with that whole thing on my calculator, not rounded or anything, I'm going to multiply by multiply by 180, and divide by pi. And the angle that I come out of there with is 38.5, if I round to the nearest tenth, degrees. So in summary, does that make sense to you? Can you make sense that the small wheel has to turn 60 degrees to travel a given arc length, and the big wheel only has to travel 38.5 degrees to travel that same arc length? Because again, with that extended radius, the arc is bigger for less number of degrees.